you can see that 1 through 5 are all pretty similar. So let's do number 4. Let's first look and see what it's telling us here. When x is less than 2, so over that region somewhere, something's going on at 2. When x is less than 2, f prime is positive. I'm trying to graph f, so I need to sort of translate that. What does that tell me about f?
It's increasing.
If f prime is positive, then f is increasing. If f double prime is positive, what does that tell me about f? Tells me I'm concave up. F is concave up. Actually, you know what? Should have read the directions to start with here. Let f of x be a continuous function, so no jumping around. F of 2 equals negative 1. So that's a point I can put on all of my graphs. F of 2 equals negative 1. So there we go. Got 1 point on there. So left of this point, I need to be increasing and concave up. So up to that point, I need to be increasing, but also concave up. Grab a pencil here. So increasing could look like that, could look like that, could look like that.
It's concave up.
But it's concave up, so which option is it? C. So I need to get rid of those others. I can just leave C there. I need to be increasing and concave up. Okay, if f prime is undefined, then I don't know what it is. That could be a cusp, it could be a vertical tangent line.
I think it's a cusp.
I think it is too. It could be undefined, but I know that's not the case because they told me that f of 2 is negative 1. So I know there's a point there. I don't think there's a point there, so it can't be a vertical tangent line. So I'm pretty sure it's a cusp. Let's see if that matches the other side here. F prime is negative. What does that tell me about f?
Yeah, I'm going down.
I sort of tried to add a third row here. So f is decreasing. Decreasing. And if f double prime is positive, then we're concave up. So I need to be decreasing, going that way, but concave up. Concave up like a cup. So something like that. And that would give me a cusp there, so I sort of automatically fit that middle piece. So why don't you try number 2? Right, yeah. Again, if it helps, make a third column for f, and then you're going to have to put actual words in there. Remember that f of 2 is negative 1. And then, to me, it's most helpful to fill in the third column about f and then try to sketch it rather than just trying to sketch it from the information. So I'm going to press pause, let you give a go at number 2. So there's the picture for number 2. Increasing concave down, increasing concave up. Now let's try number 3. I'm going to press pause and let you try. So you press pause if you're watching at home. Why don't you try number 6? Sort of the backwards problem. Complete the table below using the words positive, negative, 0, or undefined. So again, it's just backwards, like it's that's fine. Using the words or signs. kind of just thinking in reverse here. F is increasing, so that means f prime is positive. F is concave up, so that means the second derivative is positive. On the other side, f is decreasing, that means f prime is negative. F is concave down, that means the second derivative is negative. Number 8. Given the derivative of f, determine the following. Determine the intervals where f is increasing and or decreasing. Justify your answer. Let's justify our answer first. To me, that makes the problem a whole lot easier. So if I justify it, then I know what I'm looking for. So how do I justify f is increasing? Especially if I'm looking at a graph of f prime. F is increasing when f prime...
Is also increasing because f prime
Wait,
is the slope.
wait, not when f prime is increasing. When f prime is positive. When f prime is positive. Okay, so there's my justify, and then now I know what to look for. So where is f prime positive?
3 onward.
Okay, I'll take 3 onward.
And x equals.
But it's not just 3 onward. I mean, it is positive from 3 onward, but it's also positive
Everywhere else.
up to 3.
It's above 3.
Because it's decreasing, but that's not what we ask. We just want to know where f prime is positive. And f prime is almost always positive. Part B. Determine where f is concave up or concave down. Justify your answer.
I'm assuming we can't just write concave up like a cup.
No. F is concave up when f prime... I'm going to justify first. Concave down. And I have to answer in terms of f prime because that's the information I have. So concave up when f prime... You know what? It might be easier to do the double prime. Let's back up. Because when I think concave up, I think f double prime is positive. Concave down when f double prime is negative. The trouble is that's not really a justification for this problem because I don't have f double prime. I have f prime.
F prime is, or f double prime is the slope of f prime.
F double prime is the slope of f prime. So that means I can replace f double prime with slope of f prime positive or slope of f prime negative. The slope means derivative, so slope of f prime, that would be the second derivative. One last way to say that says exactly the same thing. If the slope of f prime is positive, that means f prime is increasing. So f double prime is positive when the slope of f prime is positive. That means when f prime is increasing. So look at my graph of f prime. Where is f prime increasing? Yeah, 3 to infinity. And I probably don't want to include 3 because I don't really know what's going on at 3. So I'm going to leave that as an open parentheses as opposed to a bracket.
Because you don't want to be wrong.
It's decreasing up to there, so negative infinity to 3. sketch a possible graph of f. So I think I'm going to back up and try to combine my answers here, make my own table. From negative infinity to 3, f is increasing, and 3 to infinity it's increasing. Okay, so it's increasing the whole way here. But it is, what do we say, concave up. The second part, concave down the first part. So something's happening at 3. Increasing concave down to increasing concave up. And it doesn't give me a point anywhere to start with. That's probably why it says sketch a possible graph. So I don't know where this happens. I'm just going to pick 3, 1. Concave down increasing. Concave up increasing. But that one has a lot of potential answers. Because you could have accomplished the same thing right there. Or it could have been way up here and even flatter. Like that. Lots of potential answers. They have the same f prime and f double prime. 5 more minutes. Let's look at number 12. Number 12. If you can dodge a wrench, you can dodge a dodgeball. That's number 12. That's a lot of stuff about first derivatives and second derivatives. But what I find most helpful are the actual points in there. F of 0 equals 3. F of 3 equals 0. Okay. Sort of anchor my graph. I got that part right. Now, let's see. When x is less than 0, f double prime is positive, or f prime is positive. That means f is increasing. I'm going to try to translate this onto the graph. So when x is less than 0, f is increasing. I might even go try to color code here. When x is greater than 3, f prime is positive, so that means f is increasing. Between 0 and 3, f prime is negative, so that means f is decreasing. Okay, this kind of fits so far. Alright, I got increasing, decreasing, increasing. Got a couple points. F prime of 0 is 0. That means there's a horizontal tangent line at 0. So it's a little bit of a flat spot there. Alright, when x is less than 3, the second derivative is negative. So that means second derivative is negative. That means we're concave down all the way to 3. And then after 3, we're concave up. Okay, so now I got to put all that together. So I want to be increasing and concave down. Decreasing concave down. And then increasing concave up. So it's the same as the first page. It's just there's a lot more information and a couple more intervals to worry about. So go slow, read carefully, try to color code, break it into intervals, however you want to do it. Give those a try. You've already got the review. Monday and Tuesday we'll answer all the questions you want to answer, and then we'll test on Thursday.